The objectives of this spectrum activity for the Netduino are shown on the slide. The objectives are to demonstrate the use of the three-color LED, to demonstrate reading of an analog device, in this case a potentiometer, to demonstrate the use of conditional logic, and finally to demonstrate the use of standard LEDs. This flowchart shows the flow of the program that's used for the spectrum demonstration. The program is composed of a couple of different parts. There's a lot of initialization at the beginning. We have to import the various libraries. We declare some program objects. Then we have to initialize the single LED ports for the various colors. We have to initialize the analog potentiometer input. Then we have to initialize the LEDs associated with the tricolor LED. Then we set the time delay value to 50 milliseconds before we go into the loop. There's a main loop that is a while loop. It's while true, so it's essentially an endless loop. Inside the loop, each LED is blinked for the time delay milliseconds. Then we set the time delay to the potentiometer value. We examine the potentiometer value in 3 blocks of code and use that examination to help us turn on an LED and print a message. We look to see if the time delay is less than 300, we turn on the green LED and print a message. If the time delay is between 300 and 600, then we turn on the blue LED and print the blue message. And if the time delay is greater than 600, then we turn on the red LED and print the red message. The while loop is an endless loop. It continues until you terminate the program. You see on the screen the setup I used for this experiment. I have the Netduino board fastened down with a cable tie to a Radio Shack prototyping board. You can buy the boards at Radio Shack, the prototyping boards, for about 20 bucks. On the right of it you can see that there's a bunch of LEDs. These are the colored LEDs and the 3-color LED. You can also see the potentiometer towards the center. I did some color coding of the wires here, so if I talk about the colors of the wires, you can see there's green, yellow, red, and kind of an orange color. In this slide we have a close-up which shows how some of the cables are connected to the Netduino board. You'll notice I have the power connected with the red line. The yellow line is connected to ground. That's connected to a different plane on the prototyping board. The orange wire is the analog input that's connected to the potentiometer. The green lines are connected to the LEDs for the standard single color LEDs. The blue wires are connected to the poles of the 3-color LED so that I can turn the colors of the individual LEDs inside the 3-color LED on and off. This slide shows a little bit more detail of the center part of the circuit. You can see the potentiometer in the center. One of the legs is connected to power, that's the red line. One of the legs is connected to ground, that's the blue line. And you can see the orange line is connected to the Netduino board. The potentiometer is wired up as a voltage divider. You can see 3 blue wires that come over from the Netduino and are connected to the multicolor LED. The multicolor LED has 4 legs on it. One of them is connected to ground, and the other 3 legs are set up so that each leg controls a single LED. You'll notice that I have a resistor between each of the signals out from the Netduino. That's to keep the LED from burning up. You always have to have a resistor in front of the LED. This slide shows how the single color LEDs are wired up. They're wired up in order from left to right as red, orange, yellow, green, blue, and the far right one is an ultraviolet LED. I got all of the LEDs at Radio Shack except for the blue LED, which came out of a blue flashlight. You can see the green lines across the bottom, the green wires. Those are the wires that come from the digital output ports on the Netduino. You'll notice that I have resistors here between the Netduino outputs and the LEDs, again to protect the LEDs to keep them from burning up. This diagram shows the schematic for the circuit. I used a program called Fritzing for this. You can download it off the internet for free. It doesn't have the exact schematic for the Netduino, but it does have the Arduino. Fortunately, the I/O ports are pretty much the same, So you can see what I've wired up here in terms of the various wires. It shows the potentiometer, it shows the multicolor LED, and it shows the regular single color LEDs. For your work, you'll probably want to use a package like Fritzing so that you can document your circuits and be able to save them away, and so that you can recreate them later as you need to. This video shows the circuit in operation. You can see that I have a little screwdriver on the potentiometer in the center. As the video progresses, I'm actually turning the potentiometer, and you can see that the timing of the lights for the LEDs actually varies. You can see the LEDs are moving from left to right, and they're going faster and faster as I turn the potentiometer to the right. You'll also notice that the color changes on the tricolor LED. You can see the lights are going much faster now. The color has changed, and they're going really, really fast, until finally they're going so fast that they look like they're on all the time. Now I'm turning the potentiometer to the left, and you can see that the LEDs are on longer as the potentiometer value changes. So the program is interacting with the user, flashing the lights in sequence at a different rate, and also changing the color on the multicolor LED to reflect the value on the potentiometer. This slide shows the beginning of the code for the Spectrum program. You can see that I've got some using commands up at the top. Those are to bring in all the necessary libraries. Then I have my program declaration, and I declare my main method. And as per the flowchart, if you remember from the beginning, you can see that I'm initializing single variables for the various colors, so R, O, Y, G, B, and UV. Those are set up as output ports, and you can see the actual ports or pins that those are mapped to. You can also see that I have an analog input port, A0, mapped to an analog pin, and you can see that I have the tricolor LED for red, green, and blue mapped to output pins as well. This slide shows some more of the program. You can see that I have a variable called T-delay that I set to 50. That's the initial value for the time delay, starts at 50. That is 50 milliseconds. And you can see where I start on my while loop. Now it says while true, that means it's an endless loop. I go through step by step by step, and I turn on each LED in sequence. So you can see I turn the red LED on by setting its value to true. I sleep for time delay, milliseconds, and then I turn the LED off by doing the R.write false. So I do that sequentially for red, orange, yellow, green, blue, and finally the ultraviolet. Then I have a little bit of code down at the bottom that you can see, which is going out and reading the analog input, and it's saving it into a string variable, and it's also putting it into an integer. In this slide, I've scrolled down a little bit more. You can see the code that reads the T-delay in from the potentiometer. After it reads it in, it waits for 100 milliseconds. Then it looks at the value for T-delay, and it uses 3 if-then-else tests. So it goes in, and if the T-delay is less than 300, then it turns the green LED on, and it turns the 2 other LEDs off. If the T-delay is between 300 and 600, then it turns the blue LED on and the other 2 off, and this is on the tricolor LED. And finally, if the T-delay is greater than 600, then it turns the red LED on and turns the other 2 off. This slide shows the Visual Studio console on my PC as I was actually running the program on the Netduino board. You can see that I've added a little bit of extra code up inside of the if tests. I wanted to print something out on the console so that I could see on the console what was going on with the values. So I actually print out the colors associated so that I can tell when the LED is being turned on or off. So you can see that it gives the numeric value for the potentiometer, and then right after that it also gives the color that it turns on for the associated value. This shows the same code as in the previous slide, but I've actually turned the potentiometer. If you look at the numeric values shown down in the output screen, which is where the debug output goes, you can see that the values are greater than 300 but less than 600, so the condition is set to blue inside of the if test. Finally, this slide shows the output when I've turned the potentiometer up to values greater than 600. You can see that at the bottom in the output section it's showing the value of the potentiometer greater than 600, and it's also printing out the message condition red because that's what it's printing inside of the if test down at the bottom of the code. Well, that's it for this little project. I hope you enjoyed this video on the Netduino Spectrum and they can help you in your circuits and your programming. If you subscribe to this channel, you'll be able to see when I post additional videos and you'll be able to watch them. Again, thanks for watching and have a good day.